Good morning once again to everyone, and thank you for joining this training series on Let's Learn Simulation. So, uh, as we all know, the Solid Dimension is going to have this training series on simulation on upcoming months or weeks as well. So, this training session is mainly to have focus on how the SolidWorks users can utilize the simulation or virtual simulation which is available with SolidWorks and 3D Experience simulation. So this training series will be going from the fundamentals. So basically, what are the basic fundamental for solving any finite element analysis, moving to the advanced simulation as well. And we'll be also focusing predominantly on the structural simulation part, how the structural integrity can be evaluated with respect to might be linear static or dynamic simulation, and we'll be also focusing on CFD part, that is fluid dynamics simulation, in the upcoming session as well. Right. So at the end of the training series, I believe you will be also receiving certain feedbacks or the recordings as well for your reference. And any feedbacks related to this training series, you can just put up in the Q&A session, which is available. And you can also just drop like what kind of analysis or virtual simulation you would be interested to see or learn in the SolidWorks point of view. So myself, Shamil, so I work as an application engineer for simulation at Solid Dimension. So I have overall 5 years of experience in working with as virtual simulation with respect to SolidWorks and ABAQUS. So I have certified in technical support advanced and specialist in simulation and flow simulation as well as in the ABAQUS. So in this today's training, okay. So in the today's training, we will see why simulation driven design, because most of them knows, right, how the simulation is going to play important role in their daily design activities. We will see working with pump assemblies. So straight away, I'll be jumping to the tool and focusing on how we can set up a simulation in SolidWorks. And we will also see how to set up a simulation straight away in 3D Experience ABAQUS. You all know we have a 3D Experience platform where you have lots and lots of application coming into one single platform, right? So we will also see with 3D Experience ABAQUS, right, how we can solve this problem. And straight away we will tell certain value offers offered by Solid Dimension, and at the end we will have a Q&A session. As that this training progress, any related questions or queries you can straight away put up in the Q&A session, and I'll be answering at the end of this one, right? So why simulation driven design? So this is actually everyone knows why the simulation is important, right? So first thing is product development and innovation for design validation and innovation, as you all know. So the tool, this engineering tool will helps you in the validating whatever the product you are going to design in the SolidWorks, and you can test like how it is going to behave in your real world environment. Yes, cost reduction by doing multiple iteration of simulation to meet the final requirement. You can try to run the multiple iteration, and you can save lots of material you are unwantedly using, and definitely you can also reduce the prototyping cost and time efficiency. Yes, time to market and early problem detection. So design engineers are responsible for doing any design activities, right? So at this in the same table, now you have offerings on this simulation where you can put up the real world condition, and you can see how I can go with the best optimum design with respect to the this one, and improve product quality. Yes, it will definitely enhance your performance and reliability, complex problem solving, and advanced capability, and integrated with CAD. And you all know this SolidWorks is an integrated CAD simulation software. And yes, even with the ABAQUS, now you can have a straight away whatever the design you do, there is no import or export kind of workflow coming into picture. Straight away you do the design and you can perform the simulation with respect to the Simula ABAQUS as well. And why the Simula ABAQUS? You all know, yes, when it comes to highly advanced simulation, like, so yes, this tool is for meant for the designers as well as the analysts. But when it comes to very highly non-linear problems or kind of a highly dynamics problem, it can be kind of a drop test or an impact test, that then the solver which is best in the world is something on the Simula Abacus solver, right? And sustainability and environmental impact. So I'll be not focusing more on this because you all know how simulation, what simulation brings to the table. So so let's learn simulation. Why this training series? You all know now why industries are looking for the designers who also knows the simulation, and this is what the feedback what we have received from various customers. Like they want to have the simulation engineers and expert at their in-house, and how they can improve their productivity, right? So this is what the currently industry is looking for, the designers with simulation knowledge, where they can run intermediate basic to intermediate or advanced level of simulation. So how this training series as we have planned is in 2024, this calendar here will be try to focus rather than straight away going to the advanced simulation capabilities or physics. We will be try to go through the fundamentals on FEA and CFD and basic level of knowledge and tools introduction to the engineers, and we'll be also focusing on certain example problems related to the FEA and CFD, which will be from basic to intermediate. As this series progress, I believe we'll be scheduling this training series um two series per month. This is what we have planned so far. That is basically 15 days one. As the series progress for the 1 hour series, so we will be slowly increasing the advanced capability to the simulation. And once you all have the more knowledge on this basic to intermediate level, so the next year what we have planned is focusing on intermediate to advanced level of simulation, because we have seen customers doing more prototyping testing rather than virtual simulation, and they need to implement this simulation solution. But the fact is that they are having a problem with the designers not having the knowledge of performing the simulation, or even designers things like simulation is a very big task to perform, right? So that's why we have planned for this training series, right? So straight away I will start working with SolidWorks simulation. So I'll be taking today's example. I'll be taking a simple pump assembly where I can introduce you to the tool and how to set up the simulation, what are the key parameters you have to focus, and finally how you can validate the this one. So let me open my SolidWorks. Yeah, so I have a simple pump assembly. You can see I have a pump housing here. I know you all are very good at the design point of view, right? I have a small gasket coming here and I have a pump cover, right? So basically this gasket is a non-linear material, which is rubber or kind of a non-linear material. So in this example, now I will consider it as a linear, and I will be predominantly focusing on how the displacement, or because of the internal pressure, whatever the pressure, fluid pressure is having inside, right? Because of that, how the stresses are developed on this housing and this cover, and what kind of displacement is going to happen with respect to this, right? So to activate the simulation in the add-ins, you have simulation here, or once they activated, you will be getting in the simulation tree. So once you have a simulation activated, you can cross check the products here in my products. Signaling in here, so I can see I have most of the simulation module which is available to me. So once you have the simulation and this linear static analysis, so today I'm taking on this linear static analysis, which can be also performed with your SolidWorks CAD tool, right? So once I will go to the new study, let me name it as stress analysis of pump, right? So this name, whatever the name you can give, just click on OK. So once you create a study, right, your feature manager is going to split up into two, where this is your feature manager for the design, and you have a feature manager for the simulation as well. The simulation name study is going to come at the bottom, right? So now you're going to the simulation options, and you can include certain things here in the option, like whatever the default option which you will like like to predominantly work, you can set up here. And the certainly what I usually will be bothered about this guy, the unit system. So what unit system I'll be working on, so that you can set up here, or whenever you set up a problem as a problem, you can also change the unit system at that time. So if you use one common unit system, you can set up here. This is one thing, and here need not to do anything. And these are all certain fixtures, loading condition. So what symbol color you have to get, I believe this you can go with the optimum or the whichever is in the tool. In the meshing, yes, let it be with the blended and high quality mesh. These are all the default setting. I would not recommend you to change this. And one key setting what I would tell is on the default solver. So you will always need to go to the automatic, because when you set up the solver, right, based on the number of elements or degrees of freedom, the SolidWorks solver has the capability to understand what complex simulation you are trying to solve and which is the best possible solver to use the solver, right? So one more thing is the save results rather than saving all your simulation results, because there will be too many locks created during the simulation. What I would recommend is save your simulation results under subfolder, name it as results, right? So once you run the simulation, right, wherever you have the SolidWorks file, let me tell us, project one, you have a SolidWorks file. Once you run the simulation, automatically inside the project one, the folder called results are going to create, and automatically the files are going to store inside that. So this is one, just click OK. So let me go straight away. So I will take one more advantage here. So if I see the cross section of this, you can see I have only three component coming here, and I have these bolts sitting right. So what I would do is, I know in simulation you have lots and lots of option with respect to the virtual connector, and this model is kind of symmetry, right? So to reduce the simulation time or complexity of running, or to easily run the solution, what I will do, I have created all the configuration with the half of the model, and I have removed all the bolts, because in the simulation I have straight away defining all this virtual connector. Why? Because is, if you have these bolts, right, you need to mesh all these bolts. But with virtual connectors offered inside your SolidWorks simulation, from the bolt manufacturer, whatever the diameter of the bolt, net dia, and whatever the preload torque or axial force. So as it progresses, you will understand. So I will go back. So I will just activate the configuration, this configuration. Okay, I have missed out. So new study, FEA model. I will go to the new study, stress analysis. So previously created analysis has been set to the complete model, but I'll be running for the off of the model itself. Now, how to approach the simulation? Just come from top to bottom. Your simulation will be ready. So first coming into the part, so you need to, so you can see you have two check mark here for the housing and the cover, right? So this you need not to worry, because you have already applied the material cast alloy with Young's modulus, Poisson's ratio. You can see certain things are in red color, which means these values are important for your simulation to run, or these values are predominantly considering for your material behavior, right? So if these values are not correct or is having small changes with respect to the data sheet what you are using, what I would suggest is go for the custom material. I will show how to create that custom material. So you can see in the gasket I don't have material applied. I will just exclude this surface. This surface is not needed. Okay, so just the solid of that gasket. Now let me try to apply the material. Just right click on the gasket, apply material. So I'll be going for the custom material. Whichever material you want, you can just copy, Control C, and you have a folder called custom material, right? You can create a new category, I believe. Yes, just name it of whatever the material you want. Right click and just paste it. Now what happens is, these are all the material whatever you have, these are all standard material. Once you are in custom material, right, you can change these values, right? So whatever predominantly it is there in your data sheet, I would recommend, because these are the behavior which is going to affect your results, right? So make sure whatever the values you propagate, this is as per the material you are using in your working model. right? So I have already created the material in the same way, where 84.47 is my Young's modulus, Poisson's ratio, density, and yield strength, right? So why this is in red color, why others are in blue color? So predominantly when we try to solve the linear static analysis, right? So let me explain like how the linear static analysis will be. So just an example wise, so you have a stress strain for the basic stress strain curve, what we know, okay, for the ductile material. So you are going to get the Poisson's ratio, E point, and you have yield limit here, which is your sigma y, that is yield strength. Here you are going to get your ultimate stress, and this is your fracture stress, right? So we are nowhere, and here you have a slope, which is your Young's modulus, that is the Hooke's law, right? Where stress is directly, yes, sorry. So stress is directly proportional to your strain, right? So this is your Young's modulus value E. So every material for your linear static analysis, what are the parameter which is needed is, one thing is Young's modulus of this material, and sigma y, I will tell why you need the sigma y, and the Poisson's ratio, that is basically your lateral strain to longitudinal strain, how the deformation is going to happen, that value you need, and the density of the material. So whenever a designer is going to solve a linear static analysis, or we know we have plenty of physics coming into picture, right? So whenever I tell a linear static analysis, the solver is only considering this linear curve up to this Young's model, sorry, sigma y. So linear static analysis solver will not consider this curve. It is just like the stride, this one. So how designers can come up with the point like whether my design is safe or not, right? So whenever after giving the boundary condition, fixtures or loading condition, and if you are getting the stress above this sigma y somewhere here, or because the solver is linear, it will come somewhere here, which is, let me say that sigma y is somewhere around 200 GPa, and you are getting the result somewhere around 300 GPa. From the linear static analysis itself, you can come to the conclusion that you are having a certain permanent deformation. Why? Because is once you move away from this Young's limit, right? Yield limit, right? So here is your higher yield point, lower yield point, the permanent yielding happens and the plastic deformation happen. So this is the criteria what you use, right? If your stresses are going above your yield, right? So the model is failure, right? So that is how you will put up your material behavior in the parts. So once you apply the material, you can see there is a right check mark. Yes, fine. The part folder is done, right? So next you have a connection folder coming into picture. So let me, as I told you, have lots of connectors coming in SolidWorks simulation, right? And I have suppressed all the bolts which is needed for the simulation. So what I will do, right click, I have the bolts here. Let me choose the bolt, and you have varieties of bolts offered here, and you can see other connectors also. If for example, if I am going with the welding kind of criteria, right? So I can just choose, it will ask for both the location. So in my case, it is a bolt. I will go with standard or counter bore with nut. So when you keep the cursor here, it says circular edge of the bolt head. So this is my bolt head, right? So when you keep the cursor here of the net head, so just you choose the other edge as well, right? So here you can define your head dia or net dia, if same head dia, these values, whatever the bolt you are using, you can define, and the material of the bolt, now it is taking alloy steel, which is default, or you can choose from here, or you can also input the custom if you know the strength data of the bolt. And if I click the strength data, it is asked for, so let me tell 1.5 meter threads per mm, and safety is 2, and I will go with the axial load. So whatever the preload to tighten this load, right, I will tell it is 500. So I will just spin this. So you might have one question like where I get all this data, right? So these datas you will be getting from the bolt manufacturers. So whatever the bolt you are using, right, even you can Google it and you can take out the data sheet of that. All these datas will be available in those data sheet. And I have n number of holes. That's why I have just pinned it. Why? Because is once I click OK, the bolt is created here and all the values are constant. Now I have to choose different location. So I will choose this. I will choose this, just click right check mark. So the bolt is also created there. Now I will choose this. Similarly, you have to do for all the holes. Just click mark. Create very fast. So there might be one question. If in my assembly I have some plenty of bolts, do I need to define everything manually, right? So I will tell how it is going to work. Let me choose this hole, edge, click OK, edge. Once the last one is defined, I will just uncheck. You can see all the bolts. These are called as virtual bolt. So I do not have the actual bolt here. So whatever the behavior of that bolt, I have taken into account for my simulation, and even simulation will show you that whether your bolts are safe or what kind of bolt you have to place to withstand whatever the loading condition you have, right? So you might be, most of them will be familiar with the toolbox, right? I'm not using the toolbox here. I'm not sure where it is. Simulation. Yeah, you can see now it is graded out. So if you have the toolbox component placed inside your model, and if you are taking that into simulation, if you check this bolt, right? If you have the toolbox, what happens is wherever the bolts, whichever you have used from the standard toolbox what you have in the SolidWorks CAD, right? Automatically all this is going to convert into the virtual bolts. These all things will be automatically converted if you are using the bolts from the toolbox, right? So I have done the interaction. Now I have component interaction. So component interaction, you know, it is bolted, so it is should not be bonded. I will just change into contact. So what does this bonded and contact? For example, you have, let me say this is my gasket and this is my cover, right? The interaction between this inside face and the gas cover top face, what kind of interaction it should be? Because this bolt is holding you the gasket housing as well as the cover. So you have to define it as a contact, not bonded. What happens if you have defined bonded, right? So it doesn't make any sense you placing the bolt here because these two surfaces are already bonded. It doesn't make any senses. It doesn't make any sense that you define a bolt connection here because there should be some sliding, and that whatever the shear or whatever the forces, right, that has to be withstand by these bolts, right? So that's why I have defined it as contact. So once that is done, now real world condition, just I will go with the geometry. I will fix this, right? And now you know I have only considered the half of the model, right? Now if you go to the fixtures, you have advanced fixtures, right? So here you have lots of options available. As the training series progresses, right, I'll be start using different things. So symmetry, you can see the animation here as well. So just you have to choose whichever the symmetry plane. This is my symmetry. Gasket face is my symmetry. This is my symmetry. This is my symmetry, and yeah, this face. So whatever comes in the symmetry plane, I would tell that faces you have to choose, and you have a gasket face here as well, right? So once you have selected the symmetry, you can see there is a kind of highlighted diagram. What things are, it is same kind of you can tell like the mirror thing feature what you use, but here the simulation is also going to solve, right? So if I click OK, now the symmetry has been applied. Now how it is going to take advantage, the simulation is going to solve for the entire pump assembly, but I am only going to run the meshing or in giving the input condition on these areas only. So let me come to my loading condition, pressure. So let me tell some 100 psi of pressure has been applied. So psi, so 100. So let me choose the faces where this has been. So this location, yeah, this is one, and same 100 psi pressure on these locations, the inside face of the pump. So this is my, might be my fluid pressure acting here, right? Yeah. So whatever the internal faces I have defined it as a pressure, right? So now you can see, and you have also one option like you can just uh, pressure. So this is also one good practice of renaming the things in the feature manager tree so that you will easily, rather than having pressure 1, pressure 2, you will easily understand what is the loading condition you have defined here, right? So once that is done, I will go for the machine, create mesh. So you know you have standard, where standard is predominantly you are usually for very basic analysis it is used. I would not recommend, because in standard you have only one global size. That means even though you have some important features or component in the assembly, everywhere it is going to mesh with same mesh element. That I won't suggest. And you can go with this one, blended curvature or curvature. So both options are same, blended and curvature and curvature based. So here you can input maximum, minimum, and this is minimum number of around the circle. For example, you have certain complex feature, how many elements has to capture around that feature. So I usually play from 8 to 16. When you have 16, you will get some good kind of results. So I would recommend start go with the 8 and try to run multiple iteration and try to, and you have growth ratio. Predominantly you have maximum element size and minimum element size, how the ratio of the element has to go. So you might get one more question like what size I have to define, right? So whatever the numbering what you see here, right, it is totally based on your boundary condition and the model size. So what I would usually do is I go for a first bit finer and just I will try to mesh. So it is running in other screen. Come on. Yeah, so once the meshing is done, I will just try to check the quality of the mesh. So you can go for the summary, not summary, go to the details. I will see what quality of the mesh I have got from here. So almost 95% of mesh is good, and I have very bad element of 0%. This can be also plotted. Create mesh quality plot with respect to aspect ratio. Let me change it to floating. So I can see maximum aspect ratio is 7. So basically aspect ratio, what is this is, so it is a ratio of, so here you can see these all are one tetrahedral element, solid element, right? So this ratio suggests like longer side distance to the shorter side distance. That ratio is called as aspect ratio. So if you have in SolidWorks criteria is, if you have the aspect ratio within 3, those are very good element, and within 10 it is kind of 3 to 10 it is intermediate element, and above 10, if you are getting above 10, right, those are worst element, you need to concentrate. But in some case what happens is when you have a complex kind of assembly, right, it is not easy to get entire location very good quality element. So wherever the location you have at that 10, you need to properly interpret, make suring that, for example, I have some aspect ratio of 10 at this location, my high stresses are coming from this location. That means I need to try to remesh that location, right? So if I have an aspect ratio at this edge of 10 and my pressure or higher pressures are inside this, I can just ignore it, because most of the effects are happening, or area of interest of your simulation is somewhere at this location. So once you have done this, right, straight away I would recommend to save and run. I have not saved it. So it will start solving the simulation. So this is very simple analysis. So it will not take much time. Oh, it's failed. Okay, what has went wrong? So this is fine. This is fine. The fixture is fine. Pressure. Okay, 100 psi is more. Let's try to run. Okay, I'm just go to the previous study which I have done. Okay, so gasket I have applied. This is fine. Fraction. So let me try to eliminate this bolt because I'm getting some error from there. And let me try to assume this as now bonded. Yes, I will just remesh this. So I think this is the guy. Suppress, edit definition. So I have pressure applied here. Just I will apply it from this location. So here, yeah, 100 psi. So I'm trying to put everything in this one. Let me try to mesh. So this is meshing. So let me run this analysis. Okay, just I will cancel this. No. So in the properties, I will just uncheck the large displacement. This was the guy which was creating the issue. So large displacement option is something when you have the geometric nonlinearity need to be considered. So currently I'm not considering that geometric nonlinearity. Not sure why my system is running slow. Okay, yeah, it's solving. Yeah, now you can see I have got the stresses. So if I right click, so basically this is not your actual deformation, right? So this what is happening is the deformation scale whichever you have used. So predominantly when you try to share these files to the customers, right? When they visually see, they think like you have larger displacement here. So what I will do, just I will change to the SI unit to other. I will go with the true scale, and the chart option I will try to create floating. Click OK. So now you can see the displacement. So it has been scaled actually. So just to understand in which location higher stresses are there. And if you try to annotate this, and you can see this is the location where you have higher stresses, and how you can validate is one thing, just to make sure your results are good or not. So one thing is definitely whatever the material behavior you define, and the other thing is the quality of the mesh. Make sure you have a good aspect ratio. And one more thing, what you can just see is with respect to the nodal and elemental value. Basically, what happens is if I just take this, for example, I just consider like this is my model and I have meshed with four elements, 1, 2, 3, and 4, right? And these are my nodes. These are my nodes. The results are going to calculate at different location, which is called as Gauss point. So these results are interpreted and it is going to come at each node. This is how the back end of the FEA works. So if you try to see the elemental value, it will show the elemental value, and whatever now you are seeing, this is something on the nodal value. If I change to elemental value, you can see with respect to each element, it is trying to show the values, right? So make sure there is no much difference with respect to the elemental or nodal value, and always try to take the values with respect to nodal. And one more thing is when you have a symmetry boundary condition applied, right, you have an option to display the symmetric result as well. Just locate, and you can see even though I have run the half of the model, I can get the results for all. And if I check the displacement, just animate. So you can see again, this is just a deformation scale. You can see it is almost 1400 times. And if I go back, right click, if I try to plot my factor of safety plot, just click. You can see almost my design is over designed with 4.9 times. That means you can try to withstand these pressure loading, right? You need not to have these many thickness. You can try to have some design changes. You can create certain configuration and you can straight away start running the simulation. So this is how the workflow comes. So you have to define the material property, the interaction, whatever you have, and the loading condition, that is real world condition. Once you do this, make sure you have the quality of the mesh, you make sure you have good, and finally you have can interpret the results with respect to whatever the stresses. So predominantly when you are dealing with this linear static analysis, you will be mainly focusing on how the safe of the model, whether it is going beyond the yield or not. So if in case for my loading condition, if my loading condition, right, if it has gone beyond that whatever my yield strength, that means you are having certain permanent deformation, you should try to reconfigure your model with respect to the SolidWorks, right? So let me go back. So this is how easily you can just try to solve with SolidWorks. Now coming with working with Simulia Abacus, so 3D experience. So this is not going to take more time. So 3D experience simulation uses the ABAQUS solver, right? So ABAQUS EA, you might be familiar with the ABAQUS EA, which comes in the desktop version where you have all the physics simulation in one package. Now here with 3D experience role, you have different package based on whatever physics you are trying to deal. Based on that, you can try to solve the simulation. So I will try to quickly run the one simulation using this structural designer role, right? So what is ABAQUS? So as you all know, ABAQUS, even though you know that SolidWorks, when it comes to large displacement kind of problem or kind of highly non-linear problem, SolidWorks has certain limitation, or with respect to whenever the strain rate is more with respect to large displacement problem or large non-linear problem. So ABAQUS can solve these kind of highly non-linear or highly explicit problem, and you have certain good features with respect to the simulation as well. So let me quickly show how you can. So I have a pump assembly again, half of the model. So straight away inside my SolidWorks itself, I can just save the files. So what I am trying to do is I am trying to push my, so you can see SW title is not unique because my platform has configured for not to take the duplication. Just a warning it is giving. Again, I can configure for the different case. So I'm trying to push my pump assembly to the 3D experience. So once the file is uploaded to the 3D experience, right? 3D experience platform, straight away from the SolidWorks, just go to the compass. I have to choose the simulation role, structural designer. Here you have linear static validation problem, right? So I will just name stress analysis of the pump. So I will just click OK here. So it is going to create a simulation for you and you can choose which you want. I am trying to run the static analysis or structural analysis. So once the simulation is created, you will have the assistance panel here. So part, contributing part, all these three parts will be included in my simulation. Now from the material palette, you can customize the material again here as well. So I have already used the material here. You have the feature manager tree coming here and just drag and drop whatever the material property you have. So pump steel, just I will click OK. And the gasket material, so the behavior of the material. So even though see the fundamentals remain same, only the tool usage, that is where it comes. So whatever the fundamentals or whatever the approach you use for solving a linear static analysis, it is much more same with respect to both. So to create a virtual bolt, I will just create this edge. This edge, yes. So automatically the other net edge will be automatically selected and the bolt load, whatever it is defined, 500 Newton, I can straight away define it. So you have option called bolt replication. Just you select that and choose the bolt. Automatically it will create all the bolts within the this one. So once that you have, straight away you have to define your boundary condition, so where it is fixed. And I'm just going with a planar symmetry again. Here I have considered only the half of the model just to eliminate my simulation time, right? So make sure you select all the symmetry faces which you have. Again, all these things are purely associative. So whatever the design you did in the SolidWorks, just the same model, it is coming to the 3D Experience platform. So once it's done, you can go for the loading condition, pressure load. Make sure I define it properly on both location, and all the rest of the location you have to choose wherever your boundary condition. So these call you as a engineers, you have to take a call like how exactly my loading conditions are, right? Because whatever the loading condition you give, based on that the results will be there. So based on whatever analysis you run, the loading condition, that is real world condition, boundary condition and loading, as well as the material property, you need to be more precise with respect to the simulation. So once I select, I have to just PSI. So it will automatically convert my unit system also 3D experience. Just you have to type whatever the SI units have. So once it is done, you all know we have HPC coming here to run this small. I did not to solve with that. So I will go with the, you can see I have access up to 192 cores. So it is based on the credits. So default you will have 4 cores. That means even though your computer is of 2 cores, right? So with this tool you have access straight away for the 4 cores. So this is basically you can also run in the cloud utilizing this 4 cores. So launching the simulation, acquiring the license. It's not going to take more time. Can see there are certain warnings. So errors are mainly you have to consider. Warnings are just the information or what are the things happening inside this. So you will be getting all the ABAQUS related data files in the same window. It might be the log files or the whatever the messages, how the analysis is going to progress, right? So these kind of data you can see here, the static analysis step has been created. So it's solving 100%. So it's extracting the results. Yeah. So once this is done, straight away you can try to, I need not to have the feature. The entire screen you can utilize for the post processing. And the post processing, it might be any of your tool. It might be your the ANSYS or SolidWorks or ABAQUS or other tool. The post processing remains. You will have more options to choose. You can have certain X5 plots and those stuffs. So these are the post processing tools also which is available here. So just to have as I told, certain offerings. So we are offering certain related training plus tools to our customers. So I believe who have attended the last webinar session or the training session, so they might be familiar with this. So you can have a screenshot of this. So basically SolidWorks Simulation Professional or Premium, you will get in 25 discount, and you will have a free days, 3 days free training based on whatever the model, or you will be having the first standard training and based on your model will be working. And on the flow simulation it's the same 25% discount and 2 days of training. And on the multi-physics it is both structural and CFD where you have 5 days of training, and all this offers will have the um, certification as well, right? So that's all for today's training session. So whatever the questions or queries, you can straight away put up in the Q&A session. And I would also request you to put certain physics or kind of application you are involved in, so that as the training series progress, right, I can take up such kind of similar kind of problems. I can straight away start teaching you. So if you have any questions, please let me know.